So we're facing a thunderstorm risk for July 27th, 2025 across some sections of the Northeast and portions of Eastern Ontario to Southern Quebec. So this will be mostly a non-severe thunderstorm risk, but there is some opportunity for a few strong to severe thunderstorms in these regions tomorrow. So let's do an investigation as to why, and stick with me to the end of this video to find out the actual target zones where I believe thunderstorms will initiate best. Okay, so let's do an examination of CAPE, which is convective available potential energy. It's a metric of atmospheric instability. So the brighter colors represent the highest amounts of instability. So right now we are in July 26th during the mid-afternoon. So let's go into July 27th, and you're actually starting to see those brighter colors starting to get into Eastern Ontario, Southern Quebec, parts of New York. So you're seeing that starting to overspread the regions here. And this represents CAPE of as much as 2,500 joules per kilogram. So this is relatively high CAPE for this part of the afternoon and going forward. And then you do see those darker greens starting to appear in Eastern Ontario, Southern Quebec, upstate New York. And this is starting to approach 3,000 joules per kilogram. Now let's see why that is very briefly. Okay, so one reason we have that relatively high instability, moderate to high instability, is that we're seeing a lot of sunshine getting through that cloud deck. So we do have a fairly sizable cloud deck, but the sun is able to get through, taking advantage of those breaks, and we're seeing some steep low-level lapse rates of about 7 to about even up to 9 Celsius per kilometer. So that represents some fairly steep low-level lapse rates. So this is the mid-afternoon, July 27th, and then you see those brighter reds starting to appear in Eastern Ontario in general. So we're seeing maximized instability as a result of that sunshine. Now, just skipping right ahead to 5 p.m. on July 27th, you're also seeing some fairly steep or marginally steep mid-level lapse rates joining up with those steeper low-level lapse rates that I showed previously. So these grays to even light greens represent rates of about 6 to 7 Celsius per kilometer. So that's fairly steep. So that is also contributing to the instability. Another big contribution to instability is the very high humidity, as represented by these shades of purple to dark blues. So these represent dew points of high 60s to low 70s, which is high to very high humidity. And this is for the morning of July 27th, and you start to see those purples overspreading Eastern Ontario to Southern Quebec. That would explain why we're seeing higher levels of CAPE as well, in addition to those steeper rates. Now, as mentioned, we do have our warm front that is acting as the principal lifting force in this environment for tomorrow. So this is right now for today, July 26th at 2 p.m. So let's go right into July 27th and evaluate how strong that stationary front, that stationary warm front, and we are actually seeing these reds, these brighter reds and ambers starting to appear ahead of that feature, and that is actually contributing to this maximized lift. And remember, in this area we have maximized instability as well, and then I do believe that this will be strong enough to cause at least scattered thunderstorm development from the late morning to this point in the afternoon. So this is about 5 p.m. and it's possible even into the early evening. So this is actually late afternoon around sunset. So I would still consider a risk into the late afternoon period near sunset. So this will be something to watch. And remember, this is the zone of maximized instability. Okay, so just doing a quick analysis to summarize everything we looked at. So this is our sounding profile, a skew-T-log-P diagram for the west end of Montreal. So that's where this is taken from. And this is for 5 p.m. on July 27th. So you can see this large gap, first of all. So let's look at this first. And you can see this huge area of instability represented by CAPE of about 3,000 joules per kilogram, slightly over. So that's not too surprising. We did see steep mid-level lapse rates, fairly steep lapse rates, and steeper low-level lapse rates, and of course, strong humidification at the surface is represented by this dew point of 74 Fahrenheit, so that's very high humidity. And at the same time, you're seeing this drying effect taking place too, just based on our green curve, which is the dew point temperature, and how that's changing throughout the troposphere. And you can actually see that drying effect that's taking place. So we do have ourselves what we call a hydrolapse, because the dew point, the moisture level, is actually changing very rapidly by the time we get to mid-altitudes. So this could support some potential for a damaging straight line wind hazard with some of these thunderstorms, even though the wind fields are not particularly strong at mid-altitudes. In general, this is a very somewhat unhealthy shearing profile that we're seeing throughout the troposphere. So I don't expect thunderstorms to be particularly fast moving in this situation, but it does represent a sufficient amount of speed shear to help thunderstorms become more and more organized, at least for a brief period before they actually start to weaken out. So at the same time, these are not fast moving thunderstorms overall. I mean, they're somewhat fast moving, but not terribly. And at the same time, our temperature of about -8 Celsius. So if you follow these diagonal lines up to about 500 millibars, we get a temperature of about -8 Celsius at that altitude, which is fairly cool. And it is supportive of at least some hail production in the most organized thunderstorms that form, moderate to potentially high lightning frequency with some of these. So that will be something to watch, although briefly sustained, because again, our wind shear profiles are not super strong. And I do expect this environment to stay with us right into the late afternoon, close to sunset. So that'll be something to watch as well, as our lift continues to be fairly strong at that point, at the surface at least. Remember, we're not getting that much contribution from any shortwave troughs. Okay, so based on what we looked at, just based on where the strongest lift is located, as well as where the maximized stability is also stationed, I would expect thunderstorms to pretty much form in this zone for tomorrow, July 27th, and especially during the late morning, so near traditional lunchtime to about traditional dinner time. And I would even consider some risk up to about near sunset. So that is some possibility. But I think late morning to about 5 to 6 p.m. would be the best time to see thunderstorms take advantage of this area where lift and instability are maximized. Now, again, our shearing profile isn't all that strong, so thunderstorms shouldn't be too fast moving, although they are moving at a decent pace in this sort of direction in tandem with that stationary warm front that is taking place somewhere around here at that point in the afternoon. So this area I think will be particularly notable for scattered thunderstorm coverage, and the primary hazard would be local water accumulation in this area, because remember, the thunderstorms themselves are not moving terribly quickly, so that gives them more time to spend over the same areas with heavy rainfall. So, and considering that these thunderstorms will be forming in small families, so that will also improve the chance for that local water accumulation hazard. And at the same time, as I mentioned, the wind fields, although they are fairly weak, we do have a strong drawing profile at mid altitudes, which will support a locally strong downbursting hazard. So locally strong straight line winds with some of these thunderstorms as well. So that'll be something to watch. Lightning frequency, I'm willing to go at least moderate. So this particular situation, we did see a 500 millibar temperature close to -10 Celsius. That's fairly cold. And we do have some very high moistening rates taking place at the surface. So this kind of combination will invite at least moderate lightning frequency in this target zone, I think. So moderate, potentially high, although keep in mind these thunderstorms are not lasting all that long, mostly because their sustenance is driven by the weaker wind shear. So I don't expect thunderstorms to last all that long. So therefore the lightning frequency itself, even if it does reach high standards, it won't be sustained for a long period of time. Hail production will also be very possible as well, mostly again because of those colder 500 millibar temperatures. So small hail is possible with the most organized thunderstorms in this zone. So in large part, thunderstorms should remain non-severe in severity altogether. So I don't expect these thunderstorms to be like widespread severe, but there are a handful of them that will be capable of severe criteria. So it is possible to see a severe thunderstorm watch appear in this zone at some point tomorrow afternoon. So we'll have to see if that actually happens. But if not, thunderstorms are largely non-severe, but they are able to reach, just be mindful that they can reach strong to severe standards. That's pretty much the situation for tomorrow. So if you guys made it this far, thank you very much for your attention. Really appreciate it. If you found this video useful to you and you would like to see more forecast videos for different regions, feel free to subscribe to not miss out on upcoming videos. I'd be happy to post more of these as we go further. So once again, thank you, and I'll see you in the next video. Cheers.